Hello, and welcome to Key Factor Community. I'm Sven, and today we're going to look at deploying EJBCA into the MicroK8s environment that we built in the previous video. So, without further ado, let's jump in. We're going to open up our shell, and we're going to SSH to our Kubernetes instance, the MicroK8s. We'll log in, and I wrote another little quick script here that'll run through the commands we're going to do. So the first one is creating a namespace now, where we'll run the EJBCA container. Then we're going to create some secrets, one for the database, the MariaDB container, and the other one for the database user password that will be in the EJBCA container. And we're going to create an Ingress service with the metal LB load balancer. That's the file there. So that'll get created. Then we're going to do a service. And then we'll check the containers actually to get the IP so we can see that the 172.40 is our public one. Next, we'll create the persistent volume claim. So we've got one for MariaDB and one for EJBCA, even though the EJBCA one we're not going to use, but the database one we will. So that creates, here's our service. This was the one I mentioned just previously out of the wrong order. This is where you have access within the cluster, so that way EJBCA can connect to the database and anything internal will be able to connect to EJBCA. Now we're actually going to do the deployment of the Maria database. So this is the deployment parameters for the file where we're pulling in the container. We've got how many replicas we want deployed and a lot of good on the volume claim too. So that'll go. It creates, this is the EJBCA deployment. Same things with the number of replica, the environment variables, how to connect to the database, the container we're pulling in for the EJBCA Community Edition latest. And that'll launch. So then we get to the next part of doing the Ingress networking. So what we're going to do is terminate TLS on Ingress right now and pass that back to EJBCA over AJP protocol. And we do that because TLS can automatically be set up there to get back, and then we can end up swapping out the cert later. So we'll look at the instance, and we can see that the database is up at least now under the ready for the deployment, 1 of 1, but EJBCA is still starting. So let's give it a little bit longer here and wait for the EJBCA container to launch up. And as that goes, we'll check it again. Oh, there we go. It's all set. So let's carry on. All right, so we'll go into the web browser now and actually log into this guy. So at this point, we've got EJBCA and MariaDB running in containers with the MariaDB having a persistent volume claim. So when we restart the container, it will pick right back up where we left off. And look, here we go. We can get in to EJBCA. So at this point, before you continue with the video, you need to go through the other videos of creating the hierarchy, setting up the TLS server, the TLS client, setting up roles. That way we can kick back in. So once you do that, we'll carry on right here where we're at, where we can log back into EJBCA now. And we're going to get ready to issue 2 certs. One to swap out the TLS cert on Ingress, and the other one to use with a reverse proxy HTTPD internally in the cluster. So that way any internal services can access EJBCA and vice versa through the external side. So we need to adjust the TLS server profile. We're going to add RSA key length, and we'll add the 2048 through 4096 bit size. And then we'll scroll down to the bottom, and we need to remember to select Management CA2 before we click Save. So we click that one additionally, Save. Now we'll go edit the identity profile, and we're going to add the Management CA to this one. We don't have to adjust the TLS server because we added the parts there that we need. We just need to add the management C to the identity profile. So we'll click Save. And now we can open up RAWeb, and we're going to make a new request with the TLS server profile, with the management CA, issued by the management CA, key pair generation on the CA, RSA 2048. And for the name, we're going to do EJBCA-node 1. So we'll type that in. And then on the bottom, we've already got the common name, but we also want the full cluster name to use on this. And then the username will just be EJBCA node 1. We'll do foo123. The password doesn't matter so much for this because we're just going to download a PEM. So the password's just a throwaway at this point. All right, then we're going to repeat this process, and we're going to create the second cert with EJBCA-internal for the common name of this cert. So we'll scroll back up here and swap that out to be EJBCA internal, and then the EJBCA internal with the cluster name there for the second SAN, and the username EJBCA internal, the foo123 for the username or for the passwords. We'll download the PEM. Now at this point, we need to SCP these certs up from my Mac into our virtual machine where the K8s environment is. So we'll CD over to the downloads, we'll list the PEM files, and let's SCP those up to our Kubernetes virtual machine. So we'll get ready to send these up. There we go, finish typing, put in the password. All right, our certs are there. So now we can close this tab and hop back over to our other tab. And now we're going to cat out the EJBCA node 1 file, and we're going to take the cert and the private key and the CA cert and stick those in individual files. So let's scroll up and grab the EJBCA node 1 certificate, and then we're going to use Vim to create the file with the .cert extension to put the certificate in. So we got it highlighted there. We'll do the Vim. We're going to hit I for insert, paste this, hit escape, :WQ to quit. Then we'll scroll up to grab the private key. And then we're going to create the EJBCA-node1.key, or server.key, sorry about that. Paste that in there, save and quit. And then we'll grab the CA cert, and we'll just call this one ca.crt. So we'll select that cert, and we're going to paste that in. Here we go. ca.cert, paste it, save and quit, :WQ, and then we're going to create a secret now with the Kubernetes secrets. This will be used to, the secret will be pulled in by Ingress that will relaunch Ingress now to have the TLS cert. So that way when we go back to EJBCA admin web externally, we're not going to get that cert error anymore now that we've issued a cert by the management CA that we've imported into our browser to trust. And we're going to create another secret here for the internal cert now. Same process, catting it out, grabbing the key and the cert. And since they're issued off the same CA, we can just reuse that file as well. And we'll create a secret with this, and this secret will be used for the HTTPD container for the reverse proxy, so it's terminating TLS with a cert from the management CA. So when we go to the next video of deploying an Istio service mesh, the CSR API container will hit this internal proxy, and it won't get any TLS issue now because it's going to trust the chain that's over there. And here's the Ingress file where we've got the cert with the secret that we created, that it's going to reference that. So we're going to replace the current service info with the new one now to use that TLS cert. And then we're going to set up the YAML file for the HTTPD proxy. So it's got the cluster IP that we want it to have. It's got an HTTPD config file here, and then in the bottom it's got also a volume mount where it's going to pick up the cert files that we did. And the container as well. And then we're going to save this. And we're going to do another deployment with this file to deploy that. All right, so the deployment's good. Where we've completed the install and it's ready to be used to deploy the Istio service mesh that we'll do in the next video. So stay tuned, and we'll see you in the next video to deploy a service mesh in our MicroK8s environment with EJBCA. Ciao.